We have the inside of an engine shown here. The connecting rod is 7 inches. The radius from the center of the crank is 3. Those two distances never change. However, the distance from the piston straight back to the center of the crankshaft, that does change, and your angle here changes. So when you look down here at the diagram, these two sides are the fixed sides that never change. But your angle changes, and this distance between your piston and your crankshaft would change. We want to find the velocity of the piston. Well, this is the distance to the piston here, so your velocity would just be that rate. So we're trying to find dx dt. We know that at the one instant, theta is pi over 3. However, your angle does change. So for the sake of working the problem out till the very end, you got to treat theta as a variable. Now, they do give you information up here about your derivative of your angle. It's 200 revolutions per minute. 200 revolutions per minute, but we're looking for d theta dt. So that means we're going to have units of your angle with respect to time. Well, we have the time on the bottom, so you got to think, okay, how do I change a revolution into an angle? Well, one revolution is what for your angle? And well, one revolution, you should remember, is 2 pi. So now you'll go ahead and your revolutions drop out, and you multiply what's left. You end up with 400 pi radians per minute. So we now have our units matching our derivative. Well, we're going to take that given information. We're going to have to write the equation that relates our two variables here. That would be coming from the law of cosines. Law of cosine says the side opposite your angle squared equals your adjacent side squared plus your other adjacent side squared minus 2 times your first adjacent side times your second adjacent side times the cosine of your angle. Now, that does simplify a little bit, but we can just go ahead and take the derivative as it is. Derivative of your constant is 0. Derivative of this constant is 0. Put your exponent in front, decrease your exponent by 1, derivative of x with respect to t is right here. Minus, where's the 6 come from? Your 2 times your 3. So if we just leave that in front, we now got to take the derivative of this here, but here we're multiplying stuff together for variables, so you need to use your product rule. So, derivative of the first times the second, which is what we have here at the end. So it's a 1 times the cosine of your angle. Derivative of the first is dx dt, plus the first, which is your x, times the derivative of the second. Derivative of cosine is negative sine, times the derivative of your angle with respect to t. So at this point, we're going to go ahead and simplify it a little bit. We're trying to find dx dt, so we're going to just get dx dt by itself. Once we get dx dt by itself, then all we have to do is plug in our given information. We know your angle, we know your d theta dt, but you don't know x yet. But we could go ahead and use the law of cosines to find our angle. So, or not find our angle, find x. Our law of cosines from what we started out with was this here. We now have cosine of your angle. You'll realize that this is just a quadratic equation. To solve a quadratic equation, you're going to want to have it set equal to 0. Hopefully you remember that the cosine of pi over 3 is your 1/2. Now it's just a simple quadratic equation. Z equal to 0. You should realize then you do have two numbers that multiply together to give you 40, but yet would add together to give you a -3. And so you really get two answers. You get x to be 8 and x to be -5, but keep in mind you can't use -5 because we're dealing with a length or a distance here. So your only value for x is a +8. So now we're going to take our distance of x being 8, our angle being pi over 3, our d theta dt being 400 pi, and we're going to plug it into our dx dt equation. Substituting it all in and simplifying it, we'll end up getting our answer. Remember that the sine of pi over 3 is √3/2. The cosine is a half. So then we end up with 9600 pi √3 over a -13. If we do the decimal approximation, we get about -4018 inches per minute.